Hello, welcome to the video. In this lesson, we're going to be looking at section 11.4, where we're going to be looking at three dimensional figures. So, up to this point in a majority of the mathematics that we have covered, we have looked at two-dimensional surfaces. Now we're going to dive in to some three-dimensional surfaces. And here we're going to look at three-dimensional surfaces that are polyhedrons. And also we're going to be looking at three-dimensional surfaces that are not polyhedrons. When you have a polyhedron, you have the ability to identify the number of vertices that it has, the number of edges that it has, and also the number of faces that it has. So essentially, there are two types of polyhedrons. We have the prisms, and we also have the pyramids. So depending on what your base is what you consider the name of the respected prism or pyramid. So for instance, if you had a base that was 5 sides, and that means that, okay, well, a 5-sided figure is a pentagon, and if it ended up being a prism, it would be a pentagonal prism. If it was a pyramid, it would be a pentagonal pyramid. The other types of solids, the non-polyhedrons, those are the three-dimensional figures that have a type of curvature, whether it's the cylinder, the cone, or the sphere. So anytime that you have a curve or identify some kind of a circle in the three-dimensional shape, it is not considered a polyhedron. So in these three examples, we have three-dimensional figures, and they want us, it says first is to tell whether each solid is a polyhedron. If it is, name the polyhedron. So for example A, there is no curvatures, there's no circles. So the answer is yes, it is a polyhedron. And since the base of this prism is a rectangle, it's going to be called a rectangular prism. In example B, same thing. There's no curve, so yes, it is a polyhedron. The base looks like it's 1, 2, 3, 4, 5, 6 sides. So the base is a hexagon. So the name of this would be a hexagonal prism. Or pyramid, I'm sorry. Pyramid. And C, there's the curve here. Also, you can identify that the base is a circle. So there's another way of establishing that there's curvature, so it is not a polyhedron. The name of this one is actually a cone. Doesn't ask us to name it because it said that it's not. All right, so again, these are other examples, just like what we did with the previous three examples. I would encourage you to um, check yourself, identify them. If you have questions, please let me know. So here it says describe the shape formed by the intersection of the plane and the solid. So what you're doing is anytime you're using a plane to slice a three-dimensional figure, it's a specific name. It's called a cross section. And the cross section is creating a two-dimensional object. So from that slice, depending on what kind of a polyhedron or what kind of a three-dimensional object you are getting and the angle that it is being cut at, what two-dimensional shape are you getting? So for example A, the this cross section here looks like it is a one, two, three, four, five, six-sided figure. It looks like a hexagon is the shape that this cross section is getting. For B, it turns out to be a three-sided, so it's a triangle. Um, Here for part C, when it slices into a rectangle. For D, it appears that it's going to slice into a circle. Also, it'll be a circle for E as well. And for F, it appears that it shows up as a quadrilateral, more specifically a trapezoid. Here, they want us it says sketch the solid produced by rotating the figure around the given axis, then identify and describe the solid. All right, so what is going to be happening here is you are going to be able to create a shape from this given axis. So here we have this axis, and if you were to like wrap this around, the shape that you're going to get is going to be a cylinder because try to draw this as best I can. So what I'm going to do is this is another way of describing your uh, axis. And here I'm going to put a little point right here, and then I'll make a little circle. See if I can. So what this is, or what this is representing, is from here to here is a distance of 4. And it's wrapping around this particular piece. So if I were to simply copy this over and say, okay, let's put the center right here. This gives us a distance of 9. And then we can then go about and say, all right, if we connect pieces here and here, here and here, this is identified as a cylinder. If you wanted to make it, as a drawing, you could do something like this, where this is 4, and this is a value of 9, and then this is that axis that it appears to be. If you look at the one in example B, if it wraps around that axis there, it's going to show up as a cone. And again, kind of make it however you wish to illustrate it. And then this would be a radius of 2, and then you would get your height of 5. And that is being able to look and discover three-dimensional figures. Hope this helps. Till next time.